Okay, in this problem, we're given the following reaction. PCl3 plus H2O will yield us H3PO3 plus HCl. The question stem is asking, what is the maximum amount of HCl in grams that can be produced from 20 grams of PCl? So 20 grams of PCl, how much HCl can we yield? So first things first, always balance your equation that you're given. Always double check to make sure it is balanced. And in this case, it wasn't. So let's list out how many atoms we have of each element. So phosphorus, we have 1. Chlorine, we have 3. Hydrogen, we have 2. Oxygen, we have 1. And on the product side, we have H is 4, 3 from here, 1 from there. And phosphorus, we have only 1. Oxygen, we have 3. And chlorine, we have 1. So let's start with HCl. I think that will be the easiest thing to start with for balancing. And in doing that, we have hydrogen is now 6, 3 from here, 3 from there. Phosphorus is still 1. Oxygen is still 3. And chlorine is now 3. So we have the chlorines are balanced now, as well as the phosphorus. So let's focus our attention now on the hydrogens and the oxygens. So to mitigate that, let's try adding 3 to our water here. So if we do 3 moles of water, we then get 1 phosphorus, 3 chlorines, 6 hydrogens, and 3 oxygens. And that matches up with the product side. We have 6 hydrogens, 1 phosphorus, 3 oxygens, and 3 chlorines. So this is totally balanced. Now we can get our molar ratios. So let's find the right molar ratio based on what we balanced and what we were given in the original problem and where we want to go. So we were given 20 grams of PCl3 for our reactant. And the question stem was asking for how much HCl we can yield in grams based on this reactant. So we need to find the molar ratio of how much HCl we get out of PCl3. As I've stated in previous videos, the product you want of interest always goes in the numerator. So that's like a big hint, just so that you don't flip this around and do 1 PClO3 over 3 HCl. So just keep in mind what you want in your numerator, because it's going to help you later in your stoichiometry. Okay, so next we're going to consult the periodic table so that we're able to convert what we were given, the 20 grams of PCl3, into moles of PCl3. So the molar mass of PCl3 is 137.33 grams. So this cancels out nicely to give us our moles of PCl3, which is about 0.1456 moles of PCl3. And given this, we can now use our molar ratio. So 0.1456 moles of PCl3 times our conversion factor, or the ratio, the 3 moles of HCl per 1 mole of PCl3. Our units cancel out. We can now find out how many moles of HCl we produced in this reaction. If we were just given 20 grams of PCl3, that number turns out to be 0.437 moles of HCl. Given this, we can now convert this back to grams to find out how many grams this would yield us if we were to do this reaction. So let's find out how many moles we can get, or I think I had meant to write how many grams of HCl we can get out of the moles of, oh, my bad. That's for that. I can't even read my own writing. Okay, so convert moles of HCl to grams, as I said earlier. So we were given this many moles based on our conversion factor, times that by the molar mass of HCl. So consult the periodic table again to find the molar mass of HCl. And that number turns out to be about 16. So I chose 3 significant figures based on what they listed in the question stem. 20.0 is 3 sig figs. And so I'm leaving my answer in 3 sig figs, and I'm labeling it to 16.0 grams HCl. I mean, I don't know if your teacher wants like produced, but yeah, this is the complete answer.